Hello, ladies and gentlemen, and welcome to section 2.6, Related Rates. Now, we've actually started this section just by taking the derivative implicitly of a lot of geometric formulas. Well, pictured here are several different things happening. We have a person looking at a balloon that is going up 88 meters per second. Notice that the angle of elevation is changing between the ground and the person's eyesight. Also, we have a growing sphere. Put that in quotes because that balloon is increasing in size. And as they let the gas go inside there, I think that's one of those Mentos things. And then, of course, we have this conical tank right here filling up with some kind of liquid. I'm going to assume it's water, but you never know. But we do see that we have different things changing. For instance, the angle is changing, the height of the balloon is changing, the radius of the middle balloon is changing, and the volume, of course, of the balloon is changing. With the cone, we have the volume of the cone changing, the height of the cone changing, and the radius of the cone changing. So there's a lot of things going on. A lot of related rates of change, and so we're going to investigate that today. We're going to go through some of the homework problems. So, without further ado, ladies and gentlemen, let's go ahead and show you a real quick thing here. So, how many licks does it take to get to the center of a Tootsie Pop? Yeah, this animation is kind of weird, but, you know, hey, it was on the internet, so I put it on here. So how many licks? Let's go ahead and look at a short video, ladies and gentlemen, and investigate that. Sorry if there's
Tomorrow
an ad.
is happening right now because at Enbridge we're
mute the ads real quick. So yeah, I know there's a better way of doing this. I just, you know.
Mr. Turtle, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
I never made it without biting. Ask Mr. Owl, for he is the wisest of us all.
Mr. Owl, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
A good question. Let's find out. 1, 2, 3.
If there's anything I can't stand, it's a smart owl.
How many licks does it take to get to the Tootsie Roll center of a Tootsie Pop? The world may never know.
Apparently now the world does know. Science, it would appear, does have the answer. According to a study published in the Journal of Fluid Mechanics, it takes about 1,000 licks per centimeter of candy to reach the center of almost any lollipop. And based on that math, a Tootsie Pop, which is a little more than 1 inch in diameter, would need to be licked about 2,500 times for someone to reach the Tootsie Center. You heard it here first.
If you, what I love about that video, A, that's a lot of licks. B, did you see the anchor's face? He didn't look too pleased about doing that story. He was like, really? I got my degree in journalism for this. Yep, Tootsie Rolls. All right, ladies and gentlemen. So here we go. Based in mathematics. We're going to do number 1A, so go ahead and copy this down. I'll give you some time. Of course, pause the video if you need to. Here we go. I want you to let y equal the square root of x, and I want you to find dy dt when x is 4 and the x dt is 3. Yeah, what we're doing now, we're not taking the derivative with respect to x. We're actually going to take the derivative this time with respect to t. In this section specifically, everything changes with respect to time, and the variable for time we're using is t. So let's go ahead and get this started. Well, let's see what we're going to do here. So, first let's take the derivative of y equals the square root of x with respect to t. Pause the video and see if you get what I get. Here's what I get. I get dy dt, which is the derivative of y with respect to t, is going to equal, yeah, I remember the square root rule. That's 1 over 2 square root of x times dx dt. Remember, we need to put that dx dt because we took the derivative of an x with respect to time. All right. Now, ladies and gentlemen, it's if we count the variables, we have dy dt is a variable, x is a variable, and dx dt is a variable. Well, if they want us to find any one of these variables, they have to give us the other stuff. And look at that. They do. They want us to find dy dt. So that means they have to give us x. They did. I'm going to put the square root of 4 times dx dt. Well, that's just 3. So using a calculator or whatever, ladies and gentlemen, the square root of 4 is 2. 2 times 2 is 4. And we're going to multiply that times 3. Finally, ladies and gentlemen, dy dt is going, dy dt is going to equal 3 over 4. Because 1/4 times 3 is 3/4. And that's how you do these problems. Remember I told you they always have to give you, if they give you 4 variables, they have to give you 3 of the values. If they give you 10 variables, they have to give you 9 values. That's the cool thing about this section. After we take the derivative, it's just plugging in and adding, subtracting, multiplying, and dividing, which I know for y'all will be difficult because you're calculus students and you're bad at arithmetic. Here we go. We're going to do 4b. Remember to rewind, pause, restart the video if you have to. If you want to go see that Tootsie Pop video, again, you can. Or if you just want to look at that animation, do what you want. All right, ladies and gentlemen, let x squared plus y squared equal 25. We're going to find dx dt when x is 4, y is 3, and, oops, this should say dy dt. Oh, there's already a mistake on here. Glad I caught it before we did the problem. All right, so let's go fix that real quick. dy dt. There we go. So dy dt is, because obviously if we're trying to find dx dt, I can't give you dx dt. All right, ladies and gentlemen, let's go ahead and pause the video. Take the derivative of this with respect to t and unpause it. See if you got what I got. Here's what I got. I got 2, oops. Don't not to use green on top of white. It's just bad form. 2x times dx dt. And then plus 2y dy dt. Oh, that's a y. Equals, what's the derivative of 25? Well, if you said 0, good job, because 25 doesn't change, and that means 0. Awesome. Well, we could solve for dx dt, which is great, but let's just plug in the values they give us. 2 times 4, because that's what they say x is, times dx dt, which we don't know, and we're trying to find that. And then 2 times y, they tell us y is 3, so let's put that there. And they tell us dy dt is -2. So check it out. The only thing they didn't give us was, of course, dx dt. So, by the miracle of modern, I can make this a little bit smaller so I can write some stuff. All right, here we go. 4 times 2, from here on out, is going to be 8 times dx dt. Plus 2 times 3 is 6 times -2, which is -12, equals 0. I know some people go, can you just put -12? Yeah, I can put -12, but I didn't. So bear with me, ladies and gentlemen. Here we go. I'm going to add 12 to both sides. So I'm going to get 8 dx dt is going to equal +12. And then I'm going to divide both sides by 8. So dx dt is going to equal 12 over 8. Now, for all practical purposes, that's the answer. But it can be simplified. Does anybody know what you could just simplify this by? You can. Very good answer, Asiel. That's 4. So 4 goes into 12 3 times. 4 goes into 8 twice. So the answer, ladies and gentlemen, is 3 over 2 for this one. I know it looks like a negative, but it's not. It's not. So if you're getting confused, that's 3 over 2. All right. So there you have it. That's how you do these problems, believe it or not. They do get a little bit hairier. So let's look at the next one we're going to do. And guess what? It's good old trig, ladies and gentlemen. Good old trig. So here we go. Let y equal the sine of x. Find dy dt when x is pi over 6. Yeah, they didn't have the symbol for pi. And dx dt is 2. So pause the video. Take the derivative of this with respect to t. See if you got what I got. Here we go. I hope you paused it. It's going to be dy dt equals the cosine of x times dx dt. Remember, anytime you take the derivative of something other than t, you have to put that variable dt. All right. So they want us to find dy dt. So they have to give us x and they have to give us dx dt. And look at that, they did. Genius. Dy dt is going to equal the cosine of pi over 6 times 2. And we have to take the cosine of pi over 6 first, so that's why I like to put this in parentheses. That's a cosine. I don't know what that is. Well, cosine of pi over 6. I wish I had a trig chart. Oh, I do. And the cosine of pi over 6, turns out it is the square root of 3 over 2 times 2. That's what dy dt is going to be equal to. So, since I'm multiplying, these 2's do cancel out, and the final answer for dy dt is just the square root of 3. All right. Any questions, comments, rude remarks? Let me know in the class. Here we go. Let's get into some juicier problems. Ladies and gentlemen, I have a radius of a sphere that's increasing at a rate of 2 inches per minute. Part A says, find the rate of change of the volume when r is equal to 6. So, please don't make fun of my cheap animations, ladies and gentlemen, but here's my sphere, and the rate at which the radius is increasing is 2 inches per minute. We want to find out what is the rate of change of the volume when r is equal to 6. So, what we're doing here, ladies and gentlemen, and here's what I like to do with related rates, especially when we're doing related rates, is this. First, I want to write down everything I know. It says the radius of an r is increasing at a rate of 2 inches per minute. So, what is that? That is dr dt. They're telling us the rate at which the radius is changing, and it's increasing, so it's positive 2 inches per minute. Okay? The next thing is they say, find the rate of change of the volume. Find the rate of change of the volume. That must be, they want us to find dv dt. dv dt. They want us to find dv dt when r equals 6. And 6 what? Well, 6 inches. Okay, 6 inches. Well, there's all the information we need. Okay, we got dr dt, we need to find dv dt, and we know what r is. What do we need now? Well, we need the volume formula for a sphere. Man, bet you wish your calculus teacher told you what the volume of a sphere was. Oh, he did. Yes, he did. He said that the volume of a sphere is 4/3 pi r cubed. Now, ladies and gentlemen, we're going to use our implicit differentiation tools, or just go back to your notes. Remember that this is going to be 4/3 times 3 pi r squared dr dt. Because A, we're using the power rule here. Pi is a constant, and we took the derivative of r with respect to time. Well, they want us to find dVdt. Do they give us R? Yes, they do. Do they give us dRdt? Yes, they do. So all we have to do, ladies and gentlemen, is just plug all this stuff in. So, again, I'm going to take my little stretchy thing here. No. And I'm going to go ahead and make this a little bit smaller. All right. So what we're going to do here, ladies and gentlemen, is I'm going to reduce the size of my pen there. So we're going to find dVdt. And I'm going to simplify this. These threes cancel out. So it's going to be 4 times pi times 6 squared times 2. Because that is going to be all the information they gave us. So without having to multiply by pi, ladies and gentlemen, 6 squared is 36. 36 times 2 is 72. And 72 times 4, well, that's going to give us 288 pi. Now, I want to tell you, on the AP Calculus test, ladies and gentlemen, if you get the answer correct, and you showed your derivative, we showed our derivative, and we plugged in everything correctly, and we answered the question exactly they wanted us to answer it, you need to know the units of measure. Well, you see, the radius is changing at 2 inches per minute because that's linear growth. In other words, every minute that passes by, the radius increases by 2 inches. But volume's not measured in inches, it's measured in cubic inches. So we need to write 288 pi, and there's a couple of ways you could write it. You could write it as, come on now. You can write it as let me rewrite that. Sorry about that. cc's per minute. Or you can write, and that's cubic centimeters. No, don't write that. Please don't write that. That's what I was writing. You can write CUIN per minute. That's how you write cubic inches. Or you could simply write inches cubed per minute. The units of measure on the AP Calculus test are worth 1 point. You say, well, I don't need to have that 1 point. Yeah, you do. That could be the difference between a 2 and a 3, a 3 and a 4. Okay, every point counts. So don't forget the units of measure if you do a related rates problem. All right, that's that one. So you're picking all the easy ones. I did pick some easy ones for this particular thing, but related rates aren't that difficult, ladies and gentlemen. They're really not. Here's one that's going to be a little bit more challenging. At a sand and gravel plant, sand is falling off the conveyor belt onto a conical pile at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the conical pile, or the pile, changing when the pile is 15 feet high? It's like, well, what are they giving us? Well, first of all, let's look at our little cone here. See, it has a base here, and then they're dumping sand on top of this pile, ladies and gentlemen. So what's going to happen, the height of this pile is going to increase. The height of the pile is going to get bigger and bigger and bigger and bigger. Okay? So what we want to do, ladies and gentlemen, is we want to figure out what is it that they want us to find. Okay? So a sand is falling off of a conveyor belt onto a conical pile at a rate of 10 cubic feet per minute. What is that they're giving us? Pause the video. Tell me if you could tell me. What is that? Turns out, ladies and gentlemen, hopefully you pause the video, that whenever they're telling us the, I'm sorry, I always try to use my fingers here and I can't. All right, whenever they're telling us that 10 cubic feet per minute, they're giving us the dV dt. They're actually telling us what dV dt is. dVdt is 10 cubic feet per minute. So you would write, I'm going to write ft cubed per minute. Okay? That's a minute. The diameter of the base of the cone is approximately, so the diameter is approximately 3 times the altitude. Well, another way of saying altitude is height. They like to mix the words altitude and height together. It's the same thing. Huh. That's interesting. They give us that random piece of information. It says, at what rate is the height of the pile changing when the pile is 15 feet high? So they want to know at what rate is the height changing. They want us to find dH/dt when the height is 15 feet. Okay, so we have all that information. So now we just got to go, and some of you are going, but sir, we're looking at the volume of a cone, right? So let's write the volume of a cone real quick. Let's do that. Let's write the volume of a cone. The volume of a cone, ladies and gentlemen, is trying to get this. The volume of a cone is 1/3 pi r squared h. And some of y'all are like, hey sir, we need r. We don't have any r. It's true, we don't have any r. So we're going to have to be really creative with this problem. And I will tell you, on a scale of 1 to 10, this is about I would say about an 8. Because they didn't give us some information. They did, but they didn't. And we'll talk about that. And we'll do a little bit more of this in class too. All right, ladies and gentlemen, let's see. Let's go ahead and take the derivative of this thing. And if you remember, we did do the derivative of this in class. dV/dt, that is horrible, sorry. dV/dt is going to be 1/3 pi r squared dH/dt plus 2/3 pi r h dr/dt. We took the derivative of this before, okay, and that's what we ended up getting. So the question is, what are they giving us? Well, I'm going to highlight stuff that they're giving us, all right? So they're giving us the dV/dt. They tell us that this is 10. They tell us they want us to find dH/dt, so I'm not going to highlight that. They give us h. H is 15. Sir, they didn't give us r or dr/dt. Some of y'all said, but they did tell us what the diameter was. They said the diameter is 3 times the height. What is that? How's that going to help us? Well, let me show you. Especially with cone problems, ladies and gentlemen, they like to do this. Especially with cone problems, they like to do this. Check it out. The diameter is 3 times the height. That means that 2 times r is 3 times the height. Saying, wait a minute, where did you get 2 times r? Because 2 times r is the same thing as the diameter. Because the diameter is 2 times the radius. Now, ladies and gentlemen, I'm going to go ahead and divide both sides by 2 so that r is 3/2 h. Well, how does that help us, sir? Well, if we know that the height is 15, then we know that 2/3, 3/2 times 15 will give us the radius. So the radius is 45/2, or 22.5. And remember, that's in feet. Okay? Saying, okay, so they're now telling us, going back to my highlighter, they told us what dVdt is. We now know what R is. We got to find the dHdt. We know R. We know A. Sir, they didn't tell us the RDT. You're probably saying to yourself, they didn't tell us what the RDT is, but they did. Let me show you. I know some of y'all panic. Stop panicking, all right? I'm going to help you. I'm not going to let you fail. Well, not all of you. Hey, check it out. They did tell us a lot of stuff, but they did say one thing, that the radius is 2/3, or three halves of the h, or the height, sorry. So dRdt is really 3/2 of dHdt. So they tell us that R is 3/2 of h, so the rate of change of the radius is 3/2 the rate of change of the height. So how does that help us? I'm going to show you. Ready? All right. So I'm going to make things small again. Again, rewind the video if you need to. This is a really involved problem, but it's not complicated. All right? So check this out. Saying you're making the smaller things smaller. Yeah, that's what I do. That's what I do. It's part of my job. Here we go. So I'm going to write this formula that we had calculated already. We had already calculated that dVdt was 1/3 pi r squared dHdt. And we know that it was 2/3, excuse me, pi r h. But I'm not going to put dRdt. I'm going to put times 3/2 dHdt. So why are you doing that? Well, what's the only thing that they didn't give us? They didn't give us dHdt. We know all the other stuff. So we're just going to plug that stuff in. Ready? We know that dV dt is 10. We know that R is, you know what? I did say 22.5, but you know, I'm going to keep it as 45/2 right now, because I think things are going to simplify for us. Yes, I'm sure things are going to simplify for us. And then we're going to multiply that times dHdt plus 2/3 pi times 45/2 again times 15 times 3/2 dHdt. I know I'm running out of room here. But yeah, that will be all the stuff there. All right. So let me see if I can just grab that one for another. Let me see. I'm just going to move it up like this. Again, pause the video if you need to. But I'm going to move this stuff up here because we're about to do some calculations, okay? So here are my calculations. Still got 10. Now some of y'all go, why don't you just go to another page? Okay. Control Z. Man, y'all are demanding. Control C. Let's go to another page. Ooh, white screen of death. Control V. There it is. I can hear you complaining to the video. Alright, so let's do some calculations here. I'm going to move this all the way up. I don't want to see that. I don't need to see that. I just need to see that part. Alright. Turns out a couple things happen. First thing is, that's 10 equals 1/3 times pi. Now that's going to be 45/2 times 45/2. I'm doing this, ladies and gentlemen, because things are going to is going to simplify for us, and the smaller the numbers, the better for us. So 2 over 3, got pi. I got 45 over 2 times 15 times 3 over 2 times dH dt. All right. So what it simplifies? Well, it turns out that 3 can go into 45 15 times. And that's all that simplifies on that part. Over here, 3 can cancel out with 3, 2 can cancel out with 2, and that's all that simplifies on this side. But that's still something, right? I mean, it's something. All right. So now, turns out, ladies and gentlemen, that 15 times 45 comes out to 775, if I'm not mistaken, over 4 dH dt. And you can verify for that for me on a calculator. I'm going to verify it right now on my calculator. Again, 15 times 45. Oh no, it's 626. My bad. It's 675. I was only off by 100, but that's still quite a bit. So 675. 15 times 45. All right, and yeah, that makes sense. And that's still over 4. That's fine. Don't forget that this is equal to 10. Plus, now I got 45 times 15 again. Yeah, I know what that is. And that one's going to be over 2. So I'm going to say 675 over 2 dH dt. It sure would be nice if these had common denominators. And it would be, the way to do it is just to multiply this by 2 and then multiply this by 2. Because 2 times 2 will give us 4, right? 2 times 675, that's going to be huge. But that's fine, we can do that. Let me grab this, make it smaller. Now there's several other ways you could have solved this. I'm trying to pick the least invasive way. And you're like, this is least invasive? Yeah, this is least invasive, ladies and gentlemen. So 10 is going to equal, turns out we have 675 over 4 times dH dt plus 2 times 675, I want to say is 1350. Yep, I use my calculator to verify. Over 4 dH dt. Now that those have common denominators, ladies and gentlemen, I can go ahead and add them together. That's 10 equals 675 added to 1350 is going to give us 5, 2, carry the 1, 0, carry the 1, 2. So 2025, which is my room number, by the way, not a coincidence. I mean, yeah, it is a coincidence. And now, ladies and gentlemen, to solve for dH dt, simply divide by 2025 over 4. Turns out, ladies and gentlemen, dH dt is going to equal 40 over 2025, and I'm missing a pi. Yeah, I'm missing a pi. Notice that I didn't bring down the pi's, so I'll bring down the pi's. So does that change our answer? Nope. It just puts pi in it, and everything with pi is even better. So pi is going to be in the denominator. All right. Now that could be simplified, ladies and gentlemen. It could be simplified, and then on the next page I will simplify it. But let's go ahead and write the units of measure first. No. Let's go ahead and take that, and let's simplify it on the next page. So 40 over 2025 pi turns out that the HDT is going to equal 40 over 2025 pi. This can all be simplified by, not everybody at once, 5. So this will be 8 over 405 pi. And now let's write the units of measure. The height is measured in feet per minute, so feet per minute. And you would get full credit, and you would get the 1 point for the units of measure if this was a free response question. All right, ladies and gentlemen, I will be assigning homework. Matter of fact, the homework I'm going to assign for this section is going to be problems on 2.6. I want you to do problems 2, problem 3, problem 15, problem 19, problem 22. For the time being, work on those, see what you can get done, come back to class. Oh, I left some off. I'm sorry. I also want you to do 5 and 7. Put those in there as well. All right, thank you for watching the video. Don't forget to like and subscribe this video. Peace.